Okay, now we take an integral second x to 3 dx. So we write there second x square time second x dx. Okay, so we put this second x after d. So we do that. Second x d tangent x. Why? Here, there's a formula tangent x take a derivative. So derivative equal second x square. So this direction we take derivative. So if we come back, the integral is tangent x. So now we use a partial integral. Its original formula come from here. U times v, we take a derivative, is u derivative times v plus v derivative times u. So we can write here u derivative v equal u v derivative minus v derivative u. Okay, so both sides we take integral. Integral, integral, integral. Okay, just you know this basic formula and this idea. So then you should do practice. If you don't do practice, you even you understand this formula, but you don't know how to do. When you take an exam, you can do nothing. Okay, now we come back. So we change the form integral second x time e tangent x. So now we do that here. I separate it. Second x time tangent x minus integral second x take derivative, then time tangent x dx. Okay, so here again. Second x times tangent x. So minus. So here, second x take derivative. There's another formula. Second x take derivative. Second x times tangent x. So we do that. Second x times tangent x. Then time original here, tangent x dx. So here we rewrite second x times tangent x minus second x, this tangent x, so time tangent x square dx. Again, second x, tangent x time, so minus second x, tangent x equal my, there's another formula. With so many formula, you must remember. 1 time tangent x squared equal second x squared. So that means tangent x squared equal, I write it, okay. Tangent x squared equal second x squared minus 1. So second x squared minus 1 dx. So here again, second x, tangent x, just copy. So minus second x so second x, this one, second x square, so second x 3 minus second x dx. So continue. Okay. So copy again second x tangent x minus integral second x to 3 dx. So here is minus, here minus, so plus integral second x dx. So we first we rewrite here this second x square here, second x minus square 3. So and the left original is I copy that. Second x to 3. This original question equal second x times tangent x minus second x to 3 dx plus second x dx. So here we move this part to left. So this is so negative become to positive. So we do that. 2 second x to 3 dx equal second x tangent x plus integral second x dx. So we don't finish because here still this part is the integral. We do that again. So second x tangent x plus, and this part we do second x over 1, then time tangent x plus second x So, because here denominator, we do same job. Tangent x plus secant x dx. Then equal secant x tangent x plus secant x times tangent x. Okay, just we open this brace plus secant x squared over tangent x plus secant x dx. Then we put this back to behind D. So you mean secant x is integral is tangent x. So secant x times tangent x is secant x. So we rewrite secant x tangent x plus d secant x plus tangent x over tangent x plus secant x. So that means this part secant x plus tangent x, if we take derivative, we get secant x time here. I show you here. Okay, we get the two parts, secant x times tangent x plus secant x squared. Okay. Equal secant x tangent x plus this part is, it's very easy. We can find use formula ln tangent x plus secant x, take absolute value. Why? Because this part should be larger than 0. So because if we don't do that, don't put absolute value, maybe it's negative. Negative, it's undefined. Okay. So don't forget to say, it's very easy. This still don't finish. Here, look here. This is 2. Here the 2. We don't finish. Just we redo that again. Okay, here. For you to see that clear, I rewrite 2 secant x to 3 dx equal secant x tangent x plus ln tangent x plus secant x plus c. So both sides we divide 2. So that means here secant x and dx 3. Both sides we divide 2. So that means 1 over 2 secant x tangent x plus 1 over 2 here ln absolute value tangent x plus secant x plus c. Never forget c. It's very easy, but if you forget c, you get mistake.